Hello students, welcome to my first lecture on digital memory systems. The digital memory systems is a subject that is offered in third semester of Diploma in Information Technology program. The subject is included in the curriculum to make students understand the design, types and classification of a digital memory circuit, their logical functioning and applications. Further, to comprehend basic architecture of memory systems, including processor architecture and its implementation. This subject is offered with intention to develop some outcomes or the course outcomes in the students. So the students will be able to classify digital logic families on the basis of various parameters. Students will be able to design memory registers for simple applications. Students will be able to design sequential circuits for simple applications. Students will be able to describe various types of memory architectures. Students will be able to describe various blocks of 8086 processor architecture. So these are the five course outcomes that are identified for the subject digital memory systems. This subject is having total 5 units and hence 5 course outcomes are designed mapping each to single unit of the curriculum. So let's start with the look at the university curriculum for this subject. So unit 1 is digital memory systems, which is intended to explain logic gates, classification of digital logic families based on various parameters like propagation delay, power dissipation, fan out, fan in, noise margin, etc. And finally the flip-flops. The next unit is sequential circuit design, which will make students learn types of clock pulses and their need, the race around problem and its solution, simple sequential circuit design. The Unit 3 is complex sequential circuit design. So after learning Unit 2, that is basic or sequential circuit design, some complex circuits are to be designed. So the design of advanced sequential circuit like resistors and counters is included in this chapter. Unit 4 is memory architecture and that deals with the different types of memory and their architectures. Unit 5, that is the last chapter of the subject, is processor architecture, which includes Flynn's classification, 8086 processor, and address calculations. So these are the 5 units that are to be learned by a student in the subject digital memory systems. The marks distribution as per the university curriculum is as shown here. So the highest weightage is assigned for the fifth unit, that is processor architecture, and is of total 17 marks. After the third unit is having 16 marks, fourth unit of 15 marks, second of 10, and the first unit is of 10 marks, which totals to 70. That is for the GTU external examination to be taken at the end of semester. I will be teaching you the fourth unit, that is memory architecture, and the course outcome that is mapped with the unit is describe various types of memory architectures. So after learning this unit, the students should be able to describe various types of memory architectures. So let's have a look at the different points that are to be covered in the Unit 4 memory architecture. The memory architecture itself describes the methods used to implement electronic computer data storage in a manner that is a combination of the fastest, most reliable, most durable, and least expensive way to store and retrieve information. We all are aware that a digital system should have some memory to store the data. So the storing of data and retrieval of data is a crucial task that is to be performed for a digital system. So memory architecture is responsible for the least time for storage or retrieval of the data. It should be durable. It should be least expensive in a way to store and retrieve the information. So all these things are depend or the performance of any digital system finally depends on the memory architecture that is implemented for that system. The 4.1 topic is memory classification. The computer memory can be directly divided into two parts. One is primary memory and other is the secondary memory. We all are aware that the primary memory, that what is the primary memory and what is the secondary memory. The secondary memory includes the hard disk or the major storage that is available for a computer system. While the primary memory is used or is the RAM that is available in the system for temporary storage. So primary memory can be divided into two parts, that is RAM or random access memory and ROM or read-only memory. The RAM is further divided into two parts, that is static RAM or static random access memory and a dynamic RAM or a dynamic random access memory. Similarly, ROM is divided into two parts, that is EPROM, erasable programmable ROM, and EEPROM, that is electronically erasable programmable ROM. The static RAM is more efficient than dynamic RAM and is generally used in cache memory. Similarly, the EEPROM is efficient than EPROM and is nowadays used in pen drive. So this is general classification of the memory that is available or that the computer system is dealing with. Next topic is the random access memory. So we have seen that random access memory or RAM can be divided into two parts, that is static RAM and then dynamic RAM. So what is the major difference between the static RAM and the dynamic RAM? A static RAM contains flip-flop or the flip-flops are used in a static RAM to hold the bit. So what is a bit? Bit is either a 1 or 0. When it combines, when 8 bits are combined, it forms a byte, and when we are converting that byte using ASCII codes or some other relevant codes, then we get the data. So the final storage of data in memory is in form of bits, that is either 0 or 1. So in a static RAM, the flip-flop is used to hold the bit, while in dynamic RAM, transistor and capacitor are the building blocks. So in a dynamic RAM, the capacitor stores a charge and the storage of charge in is decides whether it is 1 or 0. Static RAM does not need to be refreshed. Once the data is stored in static RAM, it will be there till the power supply is there. But in dynamic RAM, the capacitor continuously loses the charge and hence it needs dynamic refreshment. So if we want the data to be stored in a dynamic RAM, that there should be provision for dynamically refreshed to all the charged capacitor. The static RAM is comparatively expensive, while the dynamic RAM is comparatively cheaper. But the static RAM is faster while the dynamic RAM is a bit slower. Static RAM is generally used to create CPU's speed-sensitive cache. The cache memory is nearest to the processor, and the data that a processor requires is given through the cache memory. So the speed of the processor finally depends on the cache memory. So for proper equivalence between the speed of the processor and that of the memory, there should be good architecture used for the implementation of cache memory in a system. The dynamic RAM forms the larger system RAM, or it is used as a main memory in computer systems. The third topic is read-only memory. So there are certain types of ROM we will see here. The first is MROM. So it was the first basic type of ROM, that is masked ROM. So masked ROM was prepared when it the data to be written in masked ROM is written by the company itself when they are preparing the ROM. Next is the PROM, that is programmable ROM. Means the memory is available for the user to write something, but it is used once only. So once you have written some data in PROM, then it cannot be erased and it cannot be reused for storing something else. So next type is the EPROM, that is erasable and programmable ROM. Erasable and programmable ROM comes with the provision to erase the data that is stored in the memory, and again we can write something that is called programmable, and the data can be written on the memory. Next is the electronically erasable and programmable ROM, that is EEPROM. EEPROM enables the users to write data or erase data specifically at particular location also. So it is done electronically, means less efforts are required and it is easy to use. So we can give example of EEPROM is USB pen drive. The USB drives we are using nowadays to store data are using the different variants of EEPROM available. This topic also includes the design of 32 by 4 ROM, that is the design of memory or architecture of the ROM that is used in a computer system. Topic 4.4 is a programmable logic array, or we can say it is a PLA. PLA is a fixed architecture logic device with programmable AND gates followed by programmable OR gates. So PLA provides an architecture which includes AND gate and OR gate. You all are aware about the AND gates and the OR gates that you have studied earlier. So this is a arrangement of AND gates and OR gates which finally generates a PLA. In comparison with ROM, PLA is similar but does not generate all minterms. We will see what is the minterms, or you have gone through the K-maps and you have mapped or you have developed the K-maps for certain logics, so you must be know the minterms. Otherwise we will see it in detail during the further discussion on the topic. We also have to learn simple PLA design under this topic. The 4.5 topic is a cache memory that defines the or that relates to the speed of the processor. So we all are aware that a computer system is having a processor which does all the processing. The processing by a processor requires certain data. Our permanent storage is hard disk in a computer system. So whenever a processor needs data, it is to be transferred to the main memory, or we can say a random access memory or RAM. And further, to enhance the speed or minimize the time for accessing the data, some portion of data is further transferred to the cache memory. So the cache memory is nearest to the processor, and hence it requires minimum time for data access by the processor from the cache. So cache is used to reduce the average time to access data from main memory. It is smaller because it is costlier, it is faster, it requires less time, or it provides data in minimum time to the processor, and it is located closest to the processor. We will be studying about physical address model for the cache. The cache performance means what are the parameters that are defining the performance of the cache memory, and the cache addressing means how we are addressing the cache memory in a computer system. So all this was about the brief introduction for the Unit 4, that is memory architecture. We will be studying this all five topics, that is 4.1 to 4.5, in further details during successive lectures of mine in for this subject. So thank you friends. Stay home, stay home and stay safe, and keep learning these subjects. Thank you.